What is time dilation in physics? Imagine you're on a spaceship zooming through space at speeds close to the speed of light. Now, think about what would happen to time for you compared to someone staying on Earth. Time dilation is a strange effect where time itself seems to pass at different rates depending on how fast you are moving or how close you are to a massive object like a planet or star. It's a part of Einstein's theory of relativity, which tells us that time isn't fixed or absolute. Instead, it depends on your point of view. Let's say you have a clock on a spaceship and another clock on Earth. If your spaceship travels at a very high speed, near 10% of the speed of light, your clock will tick more slowly compared to the clock on Earth. This happens because the speed of light is always the same for everyone, no matter how fast they are moving. To keep this consistent, time has to slow down for the fast-moving clock. One way to picture this is with a simple light clock. Imagine a tiny mirror with a pulse of light bouncing between two mirrors. For someone standing still with the clock, the light goes straight up and down. But for someone moving alongside the clock, the light travels a longer diagonal path. Because the light speed stays the same, it takes more time for the pulse to bounce back. So, the moving clock appears to run slower. Time dilation also happens because of gravity. When you are closer to a massive object like a black hole or a planet, gravity pulls on time itself, making it pass more slowly. This gravitational time dilation has been tested with super-precise atomic clocks placed at different heights on Earth. Clocks closer to the ground, where gravity is stronger, tick a tiny bit more slowly than clocks higher up. In space, this effect becomes noticeable with objects like muons, tiny particles created high in Earth's atmosphere. These particles decay quickly, but because they move so fast, their internal clocks slow down. From our view on the ground, they seem to live longer than expected. Time dilation is not just a theory, it's used practically in technology. For example, GPS satellites orbiting Earth need their clocks corrected for both velocity and gravity effects. Without these adjustments, your navigation system would give you wrong directions very quickly. And here's a fun fact. Astronauts traveling at high speeds in space age more slowly than people on Earth. That means they actually grow a little younger in their own experience compared to us. This shows how flexible and strange the universe really is, where time can stretch or shrink depending on how fast you go or how strong gravity is where you are.